So today on 5 Minutes of Cloud, we're going to talk about containers. Specifically, we're going to talk about some of the basics. What is causing this buzz of revolution in the infrastructure services and systems deployment space? So this concept of a container is by no means new. In fact, containers have been around since at least the 70s, basically as people started taking one big computer, started breaking it down into lots of little pieces for people to use. So the timeshare systems are the ones that I think of as sort of the precursor to the container system initially. And then in the 80s and early 90s, containers were part of the larger Unix-based systems. General Unix systems had this concept of nice, which let you sort of set priority levels of different processes. And it's that process level control that has become the core of today's containers. Over the last 10 plus years now, Google actually has become a major proponent of the container services space. The focus in the Google world has been in simplifying their deployment processes, so making it easier for the developers to deploy services. And that same model actually has become a part of what people now know of as at least part of the platform as a service space, where people start looking at just bundling the specific code that their application requires. So they'll write an application in Python for a Django framework sort of environment, or Ruby on Rails, and that will then include a bunch of libraries like I need a JSON language parser, or I need something that can actually talk off to like the Square or other data processing services. I need those components that I don't have to write them myself. But I can pull all those pieces together, bundle them together, and then ask somebody else to run it. What they run it in is often a container. Now, a container in this worldview is a secure, well, semi-secure, we can talk about security in a moment, but a secured environment around which a single process and its resultant libraries run. The big change actually occurred when a company called Docker created a new format for containers. Previously, people had built containers either by directly talking to the Linux kernel and saying, hey, these particular process threads or these particular components are part of my container. Canonical actually worked alongside Google on a project called LXC, which actually took that container model and made it a little bit easier to manage. They used tools like the chroot or change root environment, so that you had the same sort of file system and environment as a Linux system expects to see, but segregated off from the bigger file system. So you were sort of in your own little enclosed container at that point. And the processes then were within that. Now, everybody still talks to the same underlying kernel, the base operating system control piece that talks to the CPU and talks to the network and talks to the disk. So there is still a shared boundary across all of these services. So there are some security concerns that come out of that. But the big shift that Docker brought to the table was a simpler way of building that chroot or that container disk environment. Making it simple through their Docker file process to just say, hey, these are the pieces I need to pull into this particular image. And each piece turned out was a little layer on the file system. So that's sort of the magic of Docker. But that is not the entirety of the container space. In reality, the Docker image format is just that. It is a way of bundling all those pieces together in a very simplistic and easy to manage, easy to deploy fashion. So developers love it because they can say, yes, I know I need an Apache library so that I can have a web service, and I need a passenger library underneath that Apache library so that my web service can actually talk to my Ruby application. And, oh, I need all these Ruby libraries, so let's install all of those using the normal processes that it would have done on a virtual machine. So that part of the Docker community is great, but beyond that, there's then the concept of a runtime, which is effectively, okay, how do I turn that system on? LXC, the canonical version of a runtime, is a fairly commonly used one. Actually, I think it's still the most used container runtime in the Linux service space, but it has been described as fairly difficult to run. So Canonical has gone off and created LXD, which provides a simplification layer on top of that. Docker has their Docker interface for managing and running containers. The CoreOS guys, which actually have a container-based operating system, everything that runs on top of it is run as a container, have the RKT or Rocket environment. And there are other services as well. These are just some of the basic ones. And then on top of that, then you say, well, okay, great, I can turn a process on or off, but that's single processes. Most people are building multi-system processes. The space of things like Kubernetes, and Mesos with the Marathon management process. There is certainly CoreOS has their Tectonic service and the core CoreOS components, and there are plenty of others. Rancher Labs is a new one that I think is actually fairly interesting from a sort of services and systems management perspective as well. All of these components are looking at effectively providing that management or operations of multiple containers layer. How do you stitch the services together? What network connectivity do I need? And beyond that, that's sort of where things are going. But this is the worldview of the container. So just in summary, came from the 1970s sort of time-sharing kind of model of, hey, how can we segregate out resources and give people what looks like their own machine, to the 80s and 90s process level management within the Unix systems environment, to Google and Canonical's work in the 90s and 2000s with the LXC class services model, and today Docker plus all of the services that run around the runtime and the management paradigms of the Kubernetes and CoreOSs of the world that provide that next level of container management. So this is the space. The growth is huge, and I think it's a very important space for us to all know. Thanks for watching. This was Robert Starmer bringing you 5 Minutes of Cloud. 5 Minutes of Cloud is brought to you by Kumulus Technologies, the company I actually work for, and we really appreciate the fact that you actually attended and watched this little segment. We obviously have a YouTube channel here, so please subscribe to that. We have Twitter. Follow me on Twitter. Yeah, I do actually find some interesting things to say on Twitter once in a while. And on top of that, we have a mailing list. If you subscribe to the mailing list, we have a free report, basically 5 pitfalls of cloud that you can avoid if you get my report. So why don't you hop on over to our website, sign up for the mailing list. You'll get that report delivered to your inbox shortly after signing up. And I think that's also another very interesting and important read. Thanks so much again for watching.